For centuries, the Yellow River, often called the Mother River of China, has nourished civilizations, forged trade routes, and reshaped landscapes with its powerful flow. In Jinan, the capital of Shandong Province, this iconic waterway forms more than just a natural boundary between the city's bustling southern districts and the developing north. It is an ever-present symbol of heritage and possibility. Yet, while the Yellow River has long been bridged, it has only recently been traversed below its mighty currents. The Jinan Yellow River Tunnel, a remarkable feat of modern engineering, represents both a culmination of decades of planning and a glimpse into the city's dynamic future. Since its earliest urban expansions, Jinan has wrestled with how to safely and efficiently connect areas on opposite sides of the Yellow River. Dikes and levees have been constructed for flood control, and bridges have spanned the waters to facilitate commerce. But no project has reshaped the landscape of connectivity quite like the tunnel beneath the riverbed. Built to withstand the forces of one of the world's most sediment-laden rivers, this tunnel is a testament to human ingenuity and determination. The concept of constructing a tunnel under the Yellow River captured local imagination. While underwater tunnels had been built elsewhere in China, tackling the Yellow River's unique challenges would require advanced technology and considerable expertise. Multiple construction methods were evaluated: immersed tube tunneling, conventional drilling, and tunnel boring machines, TBMs, each with its pros and cons. Ultimately, the tunnel boring machine approach emerged as the most viable method. It allowed for greater precision, could shield workers from direct contact with river water, and provided real-time adjustments in response to geological variations beneath the riverbed. Sourcing the right TBM became an international collaboration, with design input from leading firms around the world. Local engineers adapted these designs, ensuring the machine could manage the region's soft alluvial soils mixed with high sediment layers. After years of preparatory work and approvals, actual construction of the Jinan Yellow River Tunnel commenced in the mid-2010s. The first year of the project saw the massive TBM assembled in a launch shaft on the southern riverbank. This TBM measured several meters in diameter, weighed hundreds of tons, and was equipped with specialized cutters for abrasive soils. After careful monitoring and incremental progress, the TBM reached the midpoint beneath the Yellow River. Geological surveys were repeated throughout this phase to ensure alignment and detect any unexpected voids or rock formations. The TBM emerged on the northern side of the Yellow River, achieving the first successful under-river crossing in Jinan's history. Celebrations were modest yet symbolic, as multiple teams worked around the clock to keep up with tight deadlines. With the main tunnel boring complete, crews turned their attention to waterproofing, road surfacing, ventilation, and installation of emergency systems. Electric cabling, lighting, and CCTV systems were fitted, ensuring the tunnel would meet modern safety standards. The Jinan Yellow River Tunnel stretches several kilometers in total, with a typical vehicle tunnel width allowing multiple lanes of traffic. Compared to earlier Yellow River crossings in other Chinese cities, Jinan's tunnel introduced more advanced sediment handling technology, minimizing downtime and improving safety. Upon completion, the Jinan Yellow River Tunnel redefined travel within the city. Previously, residents and commuters relied on bridges that often experienced heavy congestion, especially during rush hours. The tunnel provided an alternative route that significantly shortened travel times between the northern and southern districts, spurring residential and commercial growth on both sides of the river. Local authorities had long envisioned a Greater Jinan, an integrated metropolis bridging what had historically been two distinct zones. By enabling fluid traffic flow, the tunnel supported that vision, encouraging real estate development and new public transport lines. Today, the area around the tunnel's northern entrance is dotted with construction sites for high-rise buildings, shopping complexes, and office parks, a testament to the tunnel's role as a catalyst for urban expansion. In the 1980s, Jinan's population stood around 2 million. Today, it exceeds 9 million in the greater metropolitan area. Urban planners estimate that the area north of the Yellow River could see a population increase of 30% over the next decade, partly due to improved access and infrastructure. From sophisticated tunnel boring machines to cutting-edge monitoring systems, The Jinan Yellow River Tunnel has showcased how modern technology can solve age-old logistical challenges. In the future, the lessons derived from Jinan's experience could be applied to other major tunneling endeavors under waterways with complex sediment characteristics. Advanced TBM technology used in the Jinan Yellow River Tunnel can handle pressure differentials of up to several bars and can excavate dozens of meters per week, depending on soil conditions. Monitoring instrumentation placed along the tunnel's length measures soil settlement and structural integrity, helping operators detect anomalies before they escalate. Even after the Jinan Yellow River Tunnel opened to traffic, its story continues. Maintenance is a core aspect of ensuring the tunnel's longevity. Scheduled inspections assess ventilation, lighting, and structural components, while automated systems monitor air quality and water leakage. In regions prone to seismic activity, such as parts of northern China, earthquake-resistant features also factor into ongoing safety protocols. Alongside routine maintenance, municipal authorities stay prepared for the river's unpredictable nature. If upstream dams release excess water, or if floods strike, the tunnel's systems can temporarily close or redirect traffic to safeguard motorists. This level of vigilance underscores how engineering marvels must coexist with the environmental realities that surround them. In Jinan, where the Yellow River's currents have shaped the city's identity for centuries, the completion of an under-river passage stands as a milestone in both engineering prowess and urban transformation. The Jinan Yellow River Tunnel is more than just a subterranean road. It is a bridge between eras, connecting the historical context of a city that has always looked to the water for sustenance with a modern vision of innovation and connectivity. These projects are not mere symbols of national pride. They are essential for sustaining a population of over 1.4 billion people, a bustling manufacturing sector, and a rapidly evolving tech-driven society. In the 20th century, China's infrastructural journey was already remarkable, particularly in the post-1978 reform and opening up era. Agriculture and manufacturing soared. Roads, ports, and power plants sprang to life, laying the groundwork for explosive economic growth. Yet, few could have predicted that by the early 21st century, China would lead the world in high-speed rail lines, erect record-breaking bridges, and construct new cities from scratch. Today, in 2025, the country's ambitions show no sign of waning. As the global community grapples with climate change, resource management, and the need for innovative transportation, China's mega-projects have become a focal point, heralded by some as feats of modernization, and by others as undertakings fraught with environmental and financial complexities. To understand the scope and ambition of China's modern megaprojects, we must trace back to the late 1970s. Under Deng Xiaoping's leadership, China initiated sweeping economic reforms that opened its markets to foreign investment and catalyzed domestic industry. In 1978, only 17.9% of China's population lived in urban areas. Today, in 2025, the figure surpasses 65%, underscoring one of the most dramatic rural-to-urban migrations in recorded history. With this influx came a desperate need for improved housing, efficient transportation, and robust public utilities. During the 1980s and 1990s, China focused on modernizing its highway system and establishing industrial zones, particularly in coastal areas like Shenzhen, which transformed from a humble fishing village to a bustling metropolis of over 17 million residents in a few decades. In the 2000s, spurred by China's entry into the World Trade Organization and the global rise of Chinese manufacturing, infrastructure investment shifted to next-level projects. High-speed rail networks, massive airports, cutting-edge power grids, and the expansion of intercity transit systems. With each new endeavor, the country's appetite for large-scale construction grew, culminating in projects that are now considered among the most ambitious on the planet. By 2020, much of the core infrastructure, like major highways and standard rail lines, was already in place. What came next were groundbreaking megaprojects designed to address specific needs, from bridging entire regions to redirecting water from water-rich areas to drought-prone provinces. In 2025, we see how these initiatives evolve, expand, and contribute to China's overarching goals for economic dominance, technological innovation, and global connectivity. The high-speed rail revolution. Few infrastructures epitomize China's rapid transformation more dramatically than its high-speed rail (HSR) network. Launched in earnest around 2008 with the opening of the Beijing-Tianjin high-speed line, China's HSR quickly eclipsed that of any other nation in terms of scope and passenger volume. In 2012, the total length of high-speed tracks stood at approximately 9,000 kilometers, a figure that, at the time, already dwarfed other countries' networks. By 2020, it reached over 35,000 kilometers, and in 2025, the system is estimated to have exceeded 45,000 kilometers, reflecting a continued annual growth rate of around 10%. The ethos driving this expansion is both practical and aspirational. On the practical side, China's vast territory requires fast and efficient travel to integrate regional economies, reduce traffic congestion, and cut down on long-haul flight dependency. On the aspirational side, the government envisions an ultra-modern transport corridor where commuting between mega-regions like the Beijing-Tianjin-Hebei cluster or the Greater Bay Area can be accomplished at speeds of up to 350 kilometers per hour. A typical journey from Beijing to Shanghai, roughly 1,300 kilometers, now takes under 5 hours by bullet train. The data underscores just how transformative this rail revolution has been for China's economy. According to official statistics, daily ridership on the HSR network surpassed 7 million by 2019 and has rebounded to near that level in 2025, following a brief downturn during global public health disruptions. Ticket prices remain relatively affordable, ensuring widespread accessibility. High-speed trains, such as the Fuxing Rejuvenation series, boast advanced engineering capabilities. Some routes even test maglev magnetic levitation technology, which can theoretically push speeds towards 600 kilometers per hour. The entire system exemplifies how massive state investment can radically alter a country's transport matrix within just 2 decades. Yet the high-speed rail venture is not without controversies. Critics note the substantial debt accrued by the China Railway Corporation and local governments to finance construction, often pointing to lower-than-expected passenger numbers in certain remote lines. Nonetheless, as 2025 unfolds, China's high-speed rail remains a cornerstone project, an unequivocal statement that the country aims to lead globally in large-scale transport engineering. The Belt and Road Initiative. Another transformative enterprise is the Belt and Road Initiative, BRI, introduced in 2013 by President Xi Jinping. Encompassing the Silk Road Economic Belt, spanning Central Asia to Europe, and the 21st Century Maritime Silk Road, linking Southeast Asia, Africa, and beyond. The BRI rapidly became the largest infrastructure and investment project in modern history. Early investments targeted railways, highways, and ports in neighboring countries. But the scope soon broadened to include energy pipelines, telecommunication networks, and special economic zones across multiple continents. By 2020, over 140 nations had signed some form of BRI cooperation agreement with China. Supporters celebrated the initiative's promise to bridge the global infrastructure gap, facilitate trade, and spur economic development in regions that had long been overlooked. Detractors, however, raised concerns about debt sustainability, environmental impact, and local job displacement. In response, China has, in recent years, emphasized green BRI guidelines, introducing measures to reduce environmental damage through more stringent oversight. Fast forward to 2025, and the BRI's evolution is evident. While some marquee projects, like the China-Pakistan Economic Corridor, have faced delays due to financing challenges and geopolitical tensions, many rail links across Central Asia have continued to expand. One shining example is the rail freight route connecting Chengdu, China, with Lodz, Poland, which has seen a 15% annual increase in cargo volume since 2022, thanks to logistical refinements and improved cross-border coordination. Likewise, a major power grid connection through Laos reached a significant milestone in early 2024, enabling the export of surplus hydropower to neighboring countries. As of 2025, Official figures suggest that total cumulative investment under the BRI framework has surpassed $1 trillion spread across multiple sectors. The initiative's future remains fluid, influenced by global economic conditions, regional security concerns, and the Chinese government's focus on sustainable development. Nonetheless, the Belt and Road Initiative stands as an audacious testament to China's aspiration to reshape economic corridors on a transcontinental scale. Beijing Daxing International Airport. Perhaps no single structure embodies China's futuristic ambitions more than the Beijing Daxing International Airport. Nicknamed the Starfish for its unique radial design, the airport opened its doors in September 2019 after 4 years of construction and an estimated $11.2 billion in costs. Designed by the late architect Zaha Hadid, Daxing Airport boasts a terminal spanning over 700,000 square meters, making it one of the largest single-building airport terminals in the world. Initially envisioned to alleviate capacity constraints at Beijing Capital International Airport, Daxing quickly became a global aviation hub. By the end of 2020, it handled approximately 16 million passengers, a figure dampened by travel restrictions of the time, but still indicative of its potential. In 2025, passenger throughput has soared well above 70 million annually, with projections placing it on track to eventually serve 100 million passengers per year. The airport's design reflects cutting-edge technology aimed at streamlining passenger experience. Automated check-in kiosks, facial recognition for security clearance, and AI-based traffic management systems reduce wait times and flight delays. The building's architecture allows natural light to flood the interior, diminishing the need for artificial lighting. Moreover, extensive use of renewable energy, such as solar power arrays installed around the premises, aligns with China's pledge for greener infrastructures. Complemented by a high-speed rail station and multiple subway lines converging beneath the terminal, Daxing is emblematic of the integrated transport approach that characterizes many of China's megaprojects. It isn't just an airport. It's a cornerstone of the broader Beijing-Tianjin-Hebei regional development plan, connecting millions of residents to global destinations with minimal friction. As air travel rebounds in 2025, Daxing International Airport stands as both a functional necessity and a symbolic gateway to China's modern future. The Hong Kong-Zhuhai-Macau Bridge. When the Hong Kong-Zhuhai-Macau Bridge, HZMB, opened to traffic in late 2018, it redefined maritime infrastructure. Stretching 55 kilometers across the Pearl River Delta, it remains the longest sea-crossing bridge tunnel system ever built. The HZMB plays a vital role in connecting the cities of Hong Kong, Zhuhai, and Macau, central to the development of the Greater Bay Area, an emerging mega-region encompassing 9 cities in Shandong Province alongside the special administrative regions of Hong Kong and Macau. Beyond its architectural grandeur, the bridge has significantly reduced travel time between Hong Kong and Zhuhai, from approximately 4 hours by car to just 30 minutes. By 2025, daily vehicular traffic has stabilized around 6,000 to 7,000 vehicles, with occasional spikes during holidays. While some critics initially labeled the project a white elephant due to high costs, around $20 billion and lower than expected usage in its early years, traffic has steadily climbed as the Greater Bay Area's economy continues to intertwine. Technologically, constructing such a lengthy sea bridge posed massive engineering challenges. 2 artificial islands were built to house the transition between the bridge and a submerged tunnel, allowing ships to pass overhead without obstructing one of the world's busiest shipping lanes. The bridge is designed to withstand typhoons, shifting ocean currents, and, according to official specifications, earthquakes of up to magnitude 8.0. Engineers tested various building materials for corrosion resistance, given the high salinity of the Pearl River estuary. By linking 3 major economic hubs, the HZMB fosters improved regional integration, boosting tourism and investment within the Greater Bay Area. In 2025, expansions in customs and immigration facilities aim to streamline cross-border flow. For many, this sea crossing project stands as an emblem of China's capacity to build at scale and tackle formidable geographic obstacles. The South-North Water Transfer Project. Unlike airports and bridges that dazzle the skyline, the South-North Water Transfer Project is a complex and understated feat of engineering, designed to address one of China's most pressing challenges: water scarcity in the north. Officially approved in 2002, this massive network of canals, aqueducts, and tunnels redirects water from the Yangtze River basin in southern China to the drought-prone north, including Beijing and Tianjin. The project consists of three main routes: eastern, middle, and western, each spanning hundreds of kilometers. The middle route, completed in 2014, stretches over 1,400 kilometers, carrying water from Danjiangkou Reservoir in Hubei Province to Beijing. By 2020, close to 9.5 billion cubic meters of water had been transferred annually through the middle route alone, benefiting approximately 53 million people. In 2025, that figure has risen slightly due to continued improvements in channel capacity and efficiency. The east route follows the path of the Grand Canal, lifting water from the lower Yangtze region toward Shandong Province through a series of pump stations. Although initial phases have been operational since 2013, progress on the east route continues, focusing on capacity upgrades and the introduction of advanced water purification facilities. Meanwhile, the most controversial section remains the western route, which is still in the planning phase. This part would cut through the Qinghai-Tibet Plateau's challenging terrain, a region of high altitude and ecological sensitivity, sparking debates on environmental impact, the displacement of local communities, and technical feasibility. Despite these challenges, the South-North Water Transfer Project has proven crucial for sustaining agricultural production, industrial needs, and everyday consumption in water-starved regions. Critics argue that long-term sustainability requires improved water conservation and pollution control, rather than massive transfers that could upset delicate ecosystems. Still, the data underscores its necessity. Beijing's per capita water availability once hovered at around 100 cubic meters per year, far below the United Nations' scarcity threshold of 1,000 cubic meters. Thanks to the ongoing improvements in water supply, the city and surrounding regions now enjoy a less precarious existence, although the road to a truly balanced water strategy remains long. Xiong'an New Area and Futuristic City Projects. In April 2017, China announced the creation of the Xiong'an New Area in Hebei Province, branding it a Millennium Strategy aimed at relieving Beijing of non-essential functions, spurring regional development, and fostering innovation-driven growth. Nestled about 100 kilometers southwest of downtown Beijing, Xiong'an has been meticulously planned as a smart city from inception, with advanced digital infrastructure, green spaces, and clean energy transit systems at its core. Early years focused on land acquisition, environmental restoration, particularly around the Bayangdian Lake, and setting up basic infrastructure like roads and utilities. By 2023, several government agencies and state-owned enterprises had relocated certain offices to Xiong'an, signaling that the area's transformation from farmland to futuristic metropolis was truly underway. In 2025, construction cranes will continue to dominate the skyline as the second stage of development unfolds, marked by the completion of key transit lines and the opening of research institutes focusing on artificial intelligence, robotics, and next-generation information technology. Detailed data on Xiong'an's growth indicates that the local population is expected to reach 2.5 million by 2035, though much will depend on how effectively the region attracts businesses and retains talent. To mitigate urban sprawl, city planners have limited building heights in certain zones, allocated large parcels for public parks, and introduced sophisticated water purification and flood management systems, all of which aim to make Xiong'an an eco-friendly template for future Chinese cities. Xiong'an is not an isolated case. Across China, other large urban centers, such as Shenzhen and Chongqing, continue to sprawl outward with planned expansions. However, Xiong'an stands out for its government-decreed vision and the high-level endorsement that places it on the same strategic tier as previous special economic zones, including Shenzhen and Pudong in Shanghai. If fully realized, Xiong'an could become a living laboratory for sustainable city building, showcasing how policy, technology, and ecological awareness can converge in an entirely new metropolitan blueprint. As China pivots toward cleaner energy and seeks more efficient power transmission, ultra-high voltage (UHV) power line projects have gained prominence. Initiated to address the inefficiencies of transmitting electricity across vast distances, China's State Grid Corporation has invested heavily in UHV lines that can operate at voltages of 800 kilovolts and above. These lines significantly reduce power losses over long distances, allowing renewable energy from western provinces, like solar power from the deserts of Xinjiang or wind power from Inner Mongolia, to feed the industrial belts in the east and south. By 2025, China reportedly has over 30 UHV transmission projects in operation, weaving together a national grid that is more resilient and more efficient than ever before. Each of these lines can carry gigawatts of electricity, enough to power millions of households while simultaneously facilitating the integration of green energy sources. The construction of these lines demands advanced technology, including specially designed transformers and towers built to endure harsh weather conditions. Proponents argue that UHV is essential for China's goal of achieving carbon neutrality by 2060, though skeptics remain concerned about high construction costs, electromagnetic radiation, and grid stability when dealing with intermittent renewable energy. Ultimately, China's craziest megaprojects stand at the forefront of human adaptability and aspiration. They illustrate how rapidly we can shape our environment when resources, political will, and technology converge. For better or worse, the blueprint of tomorrow may already be taking form on the high-speed rails, undersea tunnels, futuristic airports, and new cities of China. As we journey into the next decade, these monumental structures serve as a reminder that what was once considered impossible can, indeed, become reality, and that the future of global infrastructure may well be forged in the forging yards and construction sites of the world's most populous nation.